Can you guys hear me? Please post a yes to the channel or the chat room. Thank you. Thanks so much, Virag, Lokesh. Let me share the screen. All right, can you see the screen? Please post a yes. And in the meantime, let me open our notes from yesterday. Those who have joined today, this is the place you will find all the notes. I'm going to open the notes from one of those locations. That's a G drive. That G drive is linked to my laptop here. So we have started our notes in DevOps yesterday, and this is our notes. Right. So it's introduction. Change the language to get a better color. Right. And then this is our slides thing. If we are doing any visuals, we're usually putting in this slides. This is what we talked about yesterday, how we're going to progress. And this is one of the images. Like we said, we will have it. Let me insert that image into this thing. Just for your reference. And apart from that, we have the whole syllabus book, which is this thing, DevOps AWS Linux V1. Going to have an introduction to DevOps and also an introduction to SDLC process, which is somewhere here. Or do we have introduction to DevOps 2 times? This is introduction to DevOps. This is introduction. Okay. This is general. So I'll have to integrate both of them together. So we will start here. We'll try to understand what is DevOps, but to understand that, we'll have to understand what is SDLC. Now, this is what we're going to start with. Now, before I start with what is SDLC, we will go at a very generic pace. We will start with a very generic subject. So we're talking SDLC, software development life cycle. Or every software engineer should know this thing. Even if you don't learn it officially, you will be doing this on a daily basis. You are part of one of these areas in the life cycle. So let's see what this is, and then we will understand how this is related to DevOps. Now, there are a few concepts in shell scripts pending. I believe the chmod is also pending. Yeah, Naveen. We'll finish those things towards the end of this week. We talked about it yesterday. Don't worry, I'll cover all the things in all the areas. We're not going to miss anything. So here, before we get into DevOps, we will try to understand what is software development lifecycle. And to understand this, I want you to tell me, instead of a software development, how do you develop anything? So development lifecycle of any product. Forget software. We're not really talking about software. So let's talk about a novel. How do you develop a novel? Or let's talk about developing a product, let's say your college project. So development, let me put this date. 7. So let's try to understand development lifecycle. Forget software development and forget DevOps also. Example, let's say you're developing a college project. What would you normally do when you develop a software project? Any inputs from anybody? I'm sure some of you have developed some college projects. Any college project is good enough. We want to understand how a product evolves. So can you guys give me some 3 or 4 stages that you went through when you developed your product? It could be any product. Just name the product and then briefly tell me 3 or 4 steps that you have done. Post it to chat window. Go ahead and type it on post. I'm going to give you a couple of minutes here. It's important that you understand this concept. Only then you will realize what DevOps is. Analysis, design, development, testing, implementation. That's perfect. Huh? We did all these things in college. Okay. Design. Okay, I'm just writing it from the chart window for everybody to see. Naveen, please post direct message. Please post to everyone so that others also can see it. So analysis, design. That's the thing. So analysis, design, then development, then testing. I'm writing the things by Naveen. Testing, then implementation. That's good. Okay, what was this project, Naveen? Similar things were given by Ritik and Jayant also. So first one was given by Naveen. It's a very good one. Then Jayant and Ritik also gave similar things. So requirement gathering, then design, review, implementation, testing, launching. That's very good. All right. So we got really good stages here. What was these projects? Naveen, what was this project that you have implemented, these stages? Can you give us the name of the project or the product that you tried to use this mechanism to develop and implement? College website. Perfect, perfect, perfect. So that's basically a software again. So college website. Very good. So this is a software in a way, not in a way, it's exactly software. So Naveen has used this mechanism or this process to create a website software for his college or for a client. The same way, healthcare management, they've done it. Jayant has used a college website. That's very good. Ritik probably has done it for another thing. So when you look at it, looks like a lot of us have a design school building. Okay, Ritik has done it for design school building. That's good. So this is not really a software. It's more from a, shall I say, civil engineer or an architect perspective. Civil student, yeah. Ritik, that's what I thought. Yeah, that's wonderful. That's wonderful. That's wonderful. So here, if we take these two things that our own colleagues have done here, Naveen has done a college website. This is basically software, and he used these these steps. First, he analyzed the requirement. Means he tried to understand what this college website should have. Is it going to be a simple HTML pages, or is it going to be a database? Are the students going to log into this website with some username, password? Or they are simply going to come to this website and browse through all the pages? Where is the information stored? All that part is analysis. Now, while we are analyzing it, you will sit with the client. Probably Naveen sat with the college management, and they all discussed about what they know. Once the analysis phase is done, they came up with a basic outline, just a rough outline, prototyping. After the prototyping is done, they started developing it. Whatever code that they have developed, it could be HTML, CSS, or Java, whatever it is, JavaScript. They have developed it, and after developing, they tested it. And during the testing, if they found any problems, they went back, redeveloped it, tested it, went back, redeveloped it, tested it. And finally, once they're happy with the product, everything is implemented and given live. This is a very simple software project development that Naveen has done. Forget this thing. Let's look at a building. So building development existed even before software, right? Software started somewhere in 19, probably, very popularly started in 1995 in India. Emphasis was there in 1980. They were doing it, but very few people were doing. In US, it started somewhere in 1960. So I'll take it the oldest one, 1960. Even before 1960, the building development was still there. It's not like there were no buildings before 1960. So for a building development, let's see what are the steps that a civil engineer, our civil engineer, Ritik, has done. Ritik, again, first gathered the requirements. It's similar to what analysis is. So Ritik spoke to the client or the landlord. He asked, what do you need? What kind of building you want? What are the facilities you want? How many floors you want? What kind of walls you want? What kind of land it is? What kind of, how many rooms you need? You need a stairs or not? What kind of people are going to live in that? How is that going to be used? Is it going to be used by a family, a small family to live, or is it going to be a commercial one? So this entire requirement gathering was done. And once that is done, we came up with a design. And then we review that design. And once the review is done, see this thing here? The basic development or what is called implementation here is done. Don't worry about exact wording. It can mean different things at different levels. Just understand the rough outline. So once Ritik understood the general requirement, he gave a design that is reviewed by the landlord and himself, and they went ahead and implemented it. After they went ahead and implemented it, probably there is another review kind of thing to see if everything is moving fine or not. Then finally, basically, they went ahead and they launched the building. Now, if you see this process remains same for any type of product, not just software. So the one that we are looking here is building. If you want to try to design a robot, you would follow the same process. You first gather the requirement, then you start with a prototype, initial design, then you look at your prototype, then you implement it, then you test your prototype, make sure everything is fine. If it is not fine, then you go back to your design and then make modifications, and finally you launch it. Or if you are writing a simple, probably a book, you would do the same thing. You first decide what you want to write about. Then you come up with a rough sketch. Then you start writing it and you review it. And if you are looking at it and you are not satisfied with it, you go back and you redo your draft and come back and finally you launch it. So this process of building anything is same. So when we say development life cycle, we're talking about development life cycle of any product. And the development of life cycle of any product is pretty much same. Let me put it here. So what we were talking about just now is life cycle of development of any product. We just looked at 2 or 3 such products. So any product goes through the same process. You analyze first your requirements, then you come up with a basic design. You review it and you start implementing your basic design. And you see that your basic design is working fine or not. If it's working fine, you will move ahead. If it is not working fine, you redesign it, then you re-review it, you re-implement it. So this is what is called an iterative process or iterative process. So you design, you implement, you test, design, implement, test, design, implement, test. Our process is same for a building, for a robot, for a book, or anything. So even for a software, the development life cycle is same. It's not going to be different. Remember, guys, software is also invented by humans. So when it was invented in 1950, it was invented by non-software engineers, means they only know these things. So they created a new thing with a similar process they already know. So when we do these things, they're usually known to us. It's not like aliens have created this stuff and we don't know anything about it. No. Any product that you see in anywhere in the world, if it is created by human beings, half of it we usually know it, because we create anything new with the process that we already know. We're not going to invent something all of a sudden overnight. So the same way, software development follows a similar model. It starts with analysis. So you will first see what kind of software you need. After you do the initial analysis, you first start your prototyping. Or it's called POC, proof of concept. I'm adding some additional words here, but don't worry. It's okay if these steps are back and forth. So the proof of concept basically tells us it's possible to do this initial prototype. Once the proof of concept is done, the actual development starts. This is when you start coding. All right. After analysis, this is also called requirement gathering. So you are talking to the client, you are asking a lot of questions, you are asking what type of software they need, what are the features they should have, that kind of. It's like, let's say you are designing WhatsApp. So you will sit with the client. The client said, I need a software using which people can talk to each other. That's a description of software. WhatsApp, if you are designing WhatsApp. So client says, I need a software using which people can talk to each other. Then the client said, I don't want it to be sorry, I think I lost it all that. Disconnected for a brief moment and then I came back, right? Sorry about that. Can you guys hear me now? Please post a yes to the channel. Share the session. Let me share the session. I lost it. Don't worry, I just lost it just for a moment. So this is a WhatsApp application, and we are looking at how probably these stages have been done. So during the analysis and requirement gathering, a developer sits with a client and the client tells these things. I need a software using which people can talk to each other. Then the client says, no, I don't want it to be linked with email. I want it to be linked with a mobile number because everyone is going to use a mobile. Screen is not visible yet. I'm sharing my screen. Viral, can you see the screen now? Viral? Yes, okay, fantastic. So the client said, I want it to be linked with a mobile. Then the client said, okay, this should allow easy selfies or easy images and photos exchange. Then he said, people should be able to create groups, that kind of thing. Then they said we should be able to link it to a live location. We need live location, that kind of thing. So a big list of requirements slowly arises. This list of requirements will not be implemented at a time. Probably they started with the first one. I want people to talk to each other. And this is where they said, this should be a mobile software, not desktop software. This is a major decision they have taken. They did not really create it for desktop. Right from the very beginning, it was created for mobile. And like Naveen says, Satya says, voice calls. Later it was added. Because why? I think, yeah, even I remember now, WhatsApp calls, when they came in, everybody said the mobiles are going to be dead because WhatsApp calls are free of cost. The VoIP-based calls, these are voice over IP. Then they also came with video calls, but yeah, luckily mobile phones did not die. People still use it. But WhatsApp calls are also extremely popular. Right? So these are analysis and the points that clients gives to developer. So we are introducing a word here called developer. Let me put this thing into our design model. So we will come up slowly, or we will evolve into a diagram across all the process. So the first thing, analysis. So that's going to be our first. So let's call it analysis. analysis is done by the developers, or a group of developers or a single developer. Now it's possible that this is done for a client, or probably a group of new founders have come up with a new idea like WhatsApp guys did, and then they started to implement their own idea. This, after this analysis is done, what we are talking about here, prototyping or proof of concept. So let's add another stage here. So this is called POC, very popular word, proof of concept. First, we tell a concept, then we give a proof. Let's say, to give you an example of what it means is, let's say I'm telling you a concept like, I can make humans fly. That's my concept. I'm saying, with my product, I can make humans fly. Now people are curious, so how can you make humans fly? Because that's not possible normally. Now people are going to ask me, okay, show me how. Now that's the proof of the concept that I have just presented. My concept is, I can make people fly. So if I'm giving a concept, I need to provide a proof. So I'll have to show somehow how my concept can be implemented. Now, when people see the proof, they will give you money. With that money, you are going to build a full-blown product. So you're going to recruit more developers. You're going to start coding. You're going to start testing. Then we're going to give it to the end user, then test it more. So that's how it. So proof of concept is given to the client to ask for money or ask for approval. So this is a very early stage. There is another word for this thing. If you are into startup world or if you are developing a new product, it's called an MVP, minimum viable product. What a minimum viable product is, let's say, take the scenario of WhatsApp again. If WhatsApp guys went to a company and they asked for money. So WhatsApp guys said, okay, we're going to create a software which will allow people to talk to each other on a mobile phone, linked with their mobile number. They can make free voice calls. So we need money. When they said these things, a person who is interested in it will ask, okay, show me a POC with an MVP. So they're saying, just create a basic product, means just an interface of what we are seeing, the green interface that we normally see. All right, so let's go ahead and what's that? So this is the green interface, right? So most likely these guys have developed this mobile interface we are talking, all right, initially, and they went to a company and they started asking for money. So this is the minimum viable product, MVP. So it's actually a product, but it will not have all the features. It will have only minimum features. So using this MVP, they can do a POC. You got it? POC is a generic word, and to do a POC, you need an MVP. Now, these are all technical jargon. It's good if you know these things. If you don't know also, that's fine. But POC is a very generic word. MVP is a recent one, usually used by the startups. Even in your project, if you are into a new project, your project will create an MVP first. They will put it to the client. The client accepts your MVP and then releases new funding. And using that funding, you get your salaries. If the client is not satisfied with the MVP, the project will not move forward, which means you will be out of that project and your company will look for another project for you if it is a big company. If it is a small company, probably if their MVP is not accepted, they won't get funding
which means you'll have to look for another job. So after these two stages, now, or while these two stages are going on, this development, look at this. The development is required even for MVP. You need developers who can code. After they do the development, they're obviously going to test. Now here, you will have testers, manual and automated testing. We will talk about the importance and the difference between these two as we move forward, don't worry. After the testing is done, it usually launch, or it's usually called live or go live. This is a generic step-by-step process on how a software gets developed. And the software that we talked about is WhatsApp. Now this process, the wordings are slightly different, but the concept is pretty same as building any building. All right. So do not be overwhelmed or do not be confused by these new words. They are similar to what you already know. So you don't have to really worry that you don't know these things. So how am I going to learn these things if I'm coming from a non-IT background? No, this is not IT. This is actually non-IT. So do not worry that you do not know IT. IT is not something rocket science. Anybody can learn it. It simply requires certain amount of commitment of 2 or 3 months. That's it. Anybody can get an IT job. So here, if you look at these things, let me put it from the stages to the people or teams that are involved in these areas. That's when you get more clarity. So I'm going to put another slide. So the first set of people you're going to have in a software development lifecycle are developers. So a developer has to take all the requirements from the client. It's called analysis phase or requirement gathering phase, whatever you call it, and they start developing it. When they start developing it, it could be one developer, or it could be probably 2 or 3 developers, or if the project is really big, multiple developers. So not put multiple developers here. So all these people together will develop a product. How they interact with each other, how such a huge projects get developed, we will understand slowly. For now, let's say there are developers. Now these developers develop a product, all right, and they put it into some place, a common place. Let's call that common place a code and repository. So what they've done is they have developed code here, let's say Java code. So they've installed Eclipse on their laptop. They are really hardworking and they have developed all the Java code. When they develop the Java code, because it's developed by multiple people, all this code has to be combined together. It will go into a code repository. I'll give you a name here. The code repository, something like GitHub. We'll talk what GitHub is. So GitHub essentially is where everybody pushes their code to. Now, once this code repository has the code, it needs to be tested as per our steps here. You see, you did the analysis, then you developed a prototype up to this. Now it has to be tested. So let's say our next stage is testing. So I'm going to put a single line. Test. Testing. So here you have manual testers. All the people who learn manual testing. And then automation testing.
Now to give you actual wording, this is called QA, quality analysis. Quality analysis is nothing but verifying the quality. Quality analysis. Quality analysis is nothing but testing. So both types of testing will come into quality analysis. And for manual testing, you will write manual test cases. And for automation testing, there are a lot of frameworks. The most popular one, Selenium. All right. If you are doing Java or Python, these things, Selenium. And if you are doing Android, that kind of development, FPM and others. Don't worry about the names. For now, just try to understand that we are at a testing phase. So that is called quality assurance. After testing is done, usually the next step is to launch it. This is called prod or live. Now this is where the users are connected. So if I take this, let this out. So you basically have the users who are coming from the internet. They actually land here. So they're coming from this side. And you are sitting somewhere here. Now, when this thing happens, there are a couple of other steps also. I will, they are minor steps. I'll come to those things. But this is the main flow that you will see. So the developers will develop, they put the code somewhere. The testers will come and test it. And then the code goes to production. Users will come. All sounds really nice, right? Now, here is a problem. Okay, developers developed it and they put everything into repository. Now, for the testers to test it, this code has to be put onto a server. Is it not? For example, let's say you are putting Java. Now, where does this Java code normally get deployed? You need a Tomcat server, which means you're going to require a Tomcat server. So this is a virtual machine now. Now this is where things get really interesting. So you have to create a virtual machine, or somebody has to create a virtual machine. On this virtual machine, Tomcat has to be installed. Hello? And on this Tomcat, we need to bring the Java code that was pushed by these developers. Now somebody has to do it, right? It's not going to happen automatically. That is one area. Now, when this happens, after this happens, only then the testers can test your code on a Tomcat server. Without this thing, the testers cannot test anything. There is nothing to test here because you can't look at the code and assume that it's going to work. Compiled, it has to be built, it has to be deployed to Tomcat server, and then access to this Tomcat server should be given to the testers. Means a URL should be given to the testers. Using that URL, the testers will log into this server or this website that you have built, and they will test all the functionality. Now, let's say something they found here. Now, that's when it's called version 1.0. If they find some bug, they report it to the developer. A developer will correct the bug. They push the new code here, and somebody has to again redeploy it, which is called version 1.1. So this cycle goes on and on and on. Developer develops, somebody deploys, testers will test it, they report it back to developer, they fix it.
So like this, you have lots of versions appearing 1.1, 1.2, 1.3, 1.4. Probably it will, if the software is really a big one, it will reach 1.50. And if there are too many changes, we 2.0 it will have. So this changes. Every time there is a change in the version. Now this is where it's important. We are saying every time there is a change, it is getting deployed to the Tomcat server, right? That is done by an operations engineer. That is what you are. Nowadays, the operations engineer has been renamed as DevOps engineer. We'll talk about that in a moment, why it's renamed as DevOps engineer. But traditionally, the role was given to an operations person. It's also called infrastructure person. Basically, operations person, because all the operations here, you are taking care. So when a developer pushes the code, you are setting up a virtual machine, you are installing Tomcat server, you are bringing this Java code from the repository to the virtual machine, you are deploying it to the Tomcat server, and then giving the URL to the tester. Only then the tester can work. Now, while this whole thing happens at the very end, if everybody is happy, let's say when it reaches 2.0, everybody is happy, then you take the code and then you put it to production. So that is also an operation. You have to do it. After you put it to production, the users will come in. If they complain, you have to troubleshoot and fix it. That is again operations. So these things, for this end-to-end software development to happen, and for the product to start from developer, get tested in testing, then go to the end user, they require operation people. And that's what you are. So you are an operational expert, or you are an infrastructure expert. Developers don't know how to set up virtual machines, especially in large numbers. Developer can set up a Tomcat server here on his laptop. But if you are in production, you need a lot of such servers. All the servers will require Tomcat. And all of them have to be put behind something called a load balancer. So these things are not known to developers. They are known to operations experts or cloud experts. And that's what you are learning. Let me put it into another slide. But we lost it. So here, you're basically doing a deployment. You are creating the environment, you're deploying the environment, you're troubleshooting the environments. You are basically are the glue among all these people. Developer, tester, then you have Linux administrators, then you have network administrators. These are the core areas. Then you have DBS sometimes. These are 4 or 5 sets of people among which you are creating a glue. So you are the operations people. They're also called infra. In other words, infrastructure. It's called ops team or infra team. So you talk to the developers, find out where the code is, then deploy it to the corresponding virtual machine.
Before you doing that, you will set up that virtual machine in a cloud or somewhere. To do that setup, you will talk to the Linux administrator. You talk to the network administrator. After you got sufficient details, you set up the virtual machine, and on that virtual machine, you set up a Tomcat server. That has to be done by you, not by the team of Linux. Then onto that, you get the code from GitHub, which was actually pushed by the developer. If the code is not pushed, you talk to the developer, get the code, and then that code, you will install it on Tomcat. You make sure there is a URL for the accessing that Tomcat application. You give that URL to the testers. Here we are talking two teams. One is manual testers you will give. Automation testers also will give. We'll talk about it. And this whole cycle you will operate. Now, this whole cycle usually takes 3 months to 6 months. So every day you are doing the following things. You are creating environments. When I say environments, basically VMs, Tomcat servers, Apache servers, that kind of thing. Then you are deploying the application. It could be Java if you are in a Java project. It could be Python if you are in a Python project, Node or .NET, whatever it is. The generic name is deploying the application. So you take the code from GitHub and then you put it to corresponding server. If it is Java, you will put it to Tomcat server. If it is Python, you will put it to Python server, Node server, .NET, then now you have a .NET server. All right. After deploying, you will monitor it. And if there are any problems, you troubleshoot. These are the various things that you do, and you do it in a very repeated fashion across multiple environments. We have looked at QA environment right now. This VM that I am representing belongs to a QA environment. The same way, production environment could be there. So this I'm representing is a production environment. So what we are going to do in future as we move ahead is we have to create all these environments as we move ahead, as if we are the operations team. Now let's call it why it's called DevOps. You are most likely dealing with developers a lot of times, and to reduce the friction, there are certain tools that were introduced between operations and developers. I'll talk about those tools in our next session. But this session, let's focus on SDLC process. Now, SDLC process existed before DevOps. We are not talking DevOps yet. The process that you are seeing on the screen is a very old process. Development, put the code somewhere, then testers will come and test it. Before the testing happens, the operations team will set up everything. This iteration goes on and on and on again for 3 to 4 months. And if everything is good, it goes to production and users will access it. Now, while users are accessing it, a developer team will move ahead with the next version, v3.0. In v3.0, probably you will have different set of features. Again, that will go through the same cycle again and again and again. And then finally goes here. Now that cycle that I'm talking is what we have seen yesterday here. This is plan, the red thing. You code it, you build your software, you test your software, you release your software. Releasing is deploying to production and testing. Initially here the release is, I think here in this image, release is referring to the QA. After release is done, it gets to deployment, means it gets deployed to QA or production. After you deploy it, you operate it. Basically, you make sure everything is working, then you continuously monitor it, and then you go ahead with your next step. So this is the cycle we are talking about. And to implement this cycle, these are the various stages that are required. Now, to implement these stages, some of the products that we are seeing are here. For example, Git is a tool used by all the developers and push the code. The same way, Jenkins is a tool that we use to create a deployment. And probably Nagios or Datadog will use to make sure everything is working fine, the monitoring thing. Kubernetes we will use along with probably AWS and Docker to create the virtual machines. So using these tools, we're going to implement this mechanism. And this mechanism is the software development lifecycle. Now, this set of tools that we are looking here, they keep changing because more and more tools keep coming into the market, which will do the exact same thing. This process is not going to change. It never changed. Even now, it's the same process. A process is going to change, remain same, but the tools are going to change. Like yesterday we were talking, Nagios is not used anymore. When Splunk is not used anymore. Chef is not used anymore. So instead of Chef, people, some of them moved to Ansible, some of them moved to Terraform. So this image probably will evolve over a period of time, but this in-between thing will remain same. It is always same. It was always same. For the last 50 years, it's always same. It never changed. What changes is the things around it. Now, what we have to understand is, how is this current situation? What are the current tools? And why we are calling this SDLC process as DevOps process? What's the difference between SDLC and DevOps? Now, that difference is a quick one. It will take about 5 to 10 minutes. So once I give you the difference, then we will move on to the key tools that we're going to see, and then we will start building this project end to end. So as we progress with each of these tools, we will be building from left to right. So by the time we finish this DevOps and AWS, probably we will have 2 or 3 such projects live and end to end. All right. So that's your SDLC process. That's all for today. Tomorrow we will introduce DevOps, and we will also introduce our first tool, Git and GitHub. Any questions from today's discussion?
Sir, like, are we going to discuss the in-depth on Docker, or so, because like you said on Kubernetes, like we won't discuss in depth, right? So
Docker we will. Docker is a small talk. We will discuss in depth on Docker.
okay, so why won't we are into the Kubernetes, sir? Is
Kubernetes, I think, is 2 things. One is it's complicated. Means I'm not sure if all of you will understand it, because I will just teach it, but unless you practice it, it's not going to be really useful. One thing. Second thing, Kubernetes, I mean, I'm not sure all of you are actually getting into DevOps and AWS jobs. So, it would be overcomplicating your job search process if we get into too much Kubernetes. And little bit of Kubernetes is more than sufficient at this point of time. Means people are getting jobs even with 20-30% of Kubernetes. So if we are getting jobs at 20-30%, why learn 100%? Why you put unnecessary effort? Instead, I would say you get a job with the 20% itself, then you learn Kubernetes later while you are getting your money. Your focus has to be on getting a job or a better package. That's the reason I don't want to go too deep into Kubernetes. It's not necessary. 20%, 30% of Kubernetes will get you a job. So we'll stick to that part only. Let's not overcome.
yeah, okay, sir. So AWS, like as usual, right, sir? I think on each service we are going
Yes.
right, sir?
Yeah.
I think we are
will
going,
graduate.
yeah, I think we are going to discuss around 4 to 5 services, I think so, right, sir? VPC and
We are
IST.
going to discuss 6 verticals. In 6 verticals, we'll be talking about 15 to 20 services, the key services.
Okay, so on in-depth, sir, or like how?
All real time.
Okay, sir.
Nothing related to, no theory concept, anything that is required for your interview and anything that is required for your practical work.
Okay, sir.
Only those things. We will focus on your ability to work efficiently and your ability to crack interviews using that knowledge. That's what we want, right? We don't want to be experts on AWS.
Yes, sir. And sir, how soon we can expect the completion of this course, sir?
It's going to take 3 months, both of them together, DevOps, AWS.
Okay.
Now that all of you guys are very good with Linux, you guys are with me. So
Yeah, yes, sir. Correct.
wherever it is, I'll go a little faster and we'll focus more on hands-on real-time.
Yeah, I think it's sir, it's like better to start our weekend classes, sir, so that we can cover more things.
Weekend is really unpredictable for me.
Oh.
So I don't want to commit our weekend and then disappoint you guys. So I'm little careful over the weekend. We will be able to cover with the weekdays itself. All that I have to do is make sure we're not skipping any classes. We'll still be able to cover a very good amount of solid real-time things. Don't worry.
Okay, so why? Because like in between the weekdays also, so
True. Yeah, that's what I'm trying to avoid as much as possible. So we'll make sure we are having classes consistently.
yeah. Okay, sir. Thank you.
Any other questions, guys?
Hello, sir.
Yeah.
Sir, sorry for that. Actually, some of the due to internet connection, you said that Kubernetes is also will cover for this course, right?
Yes. We'll cover. Yes.
Okay. Because it is very important, sir. I'm requesting, sir.
It is. I like Kubernetes. I really want to teach Kubernetes because that's what is going to get you jobs. If you say you know Kubernetes, you'll get a call and you will get an interview schedule. If you say you know Jenkins, nobody cares nowadays. People stopped using Jenkins. A lot of people moved to GitLab. Jenkins is a pain thing, and it's open source, right? Nobody is there to support it, so it keeps crashing. So Jenkins, people will ask you just to realize that, okay, you know the regular Jenkins process, but they won't be using Jenkins inside the project, very likely. They'll be using another tool like GitLab or CodeShip, or there are a lot of other tools. So Jenkins is for conceptual understanding. Everybody will ask, but actual use is something else. Maybe we can create a GitLab account and then try to see those things. So we'll see that, but on a sidelines, it's more like a value addition. Our core area is going to be Jenkins. DevOps is moving really rapidly, guys, because there are a lot of tools that are coming out. So companies have started experimenting with everything. Recently, we have started experimenting with something called drone CI. Drone CI is a lot better than Jenkins. So we thought, let's do a POC, and we created a MVP. We are presenting it to the client. The client says, okay, let's go ahead and use it. Then the Jenkins is gone. Because drone can be easily implemented on Kubernetes. So a lot of things will come. Don't worry about the new things that are about to come. You learn one thing and you understand the concepts. All the future things are built on top of existing things on. So once your primary objective should be to get into some kind of job. Once you get into some kind of job, then you can keep learning while you're getting your salary. Learning when you're getting your salary is easy. All right, so we will be focusing majorly on real-time stuff, getting your cracking your interview, that kind of stuff. Yesterday, somebody asked me Linux questions. I forgot that thing. I'll try to get it tomorrow. I think Naveen or Satya has asked. All right. Okay,
Sir.
guys. So that will be, yeah.
Sir, GitLab is also open source, right?
GitLab is open source, but they need enterprise support. It has enterprise support. Means there is a company which gives, you can do it on your own if you have installed it on your own. But if you don't want to go through the pain of managing GitLab, they will manage it for you. You pay them money. So you don't need GitLab administrators. But for Jenkins, there is no such thing. You have to install Jenkins. You have to manage Jenkins. Let's say Jenkins itself crashed. There's nobody to fix that Jenkins crash. Your DevOps team has to do it. Whereas GitLab, if GitLab crashes, you can talk to the gitlab.com guys. They have their engineers and they will support you. You see the pricing here? Free, it's free is there. You can install it on your own kind of thing. But if you really go with a large number of builds, other thing, you can actually pay them money. They will do all the support and hosting also. All right. It's going to be fun, guys, learning this whole thing. I really want you guys to get job. Market is picking up again. It was dull till last week. During the last week, it actually picked up.
Now
So
pick it up,
probably,
right, sir?
Sir, sir, like, are we going to discuss the installation of the Kubernetes and this lens ID and everything, right, sir?
Yes, we're going to discuss the installations, but nowadays nobody is using installation. They are using managed services, but we will discuss. You have to know them as a DevOps engineer. You should know how to do this installation.
We are going to practice this installation of the Kubernetes also, right, sir?
Yes.
Lens ID.
Yeah.
Yeah, okay, sir.
All right. Okay, guys. Thank you very much. I'll
Sir,
see you
sir.
tomorrow. Yeah.
One more. Yes. Some 2 or 3 classes pending for Linux.
Yeah, everybody is raising that. We will try to close them by probably this Saturday. There's one session that we have for shell scripting functions. We have, and then we have position parameters.
Okay.
Couple of internal variables we have to discuss. That will be about 30 minutes. And then we have Mr. CH mode for some of you guys. So I'm going to discuss that CH mode.
Yes.
And LS-LTR along with it. And those are some key concepts we will cover.
Hello, sir.
Yeah.
Sir, as now I am fresher, just passed out in 2022. If after completion of this course, DevOps, AWS, and Linux, if I mention this course in my resume, then how much package should I get, sir? Expected?
2022. You're joining as a fresher, or you're going to try as an experienced person?
Sir, as I am a fresher, sir, just passed out in 2022.
I'll doubt if they actually treat you as experience, but because you have more knowledge compared to others, and these, especially with Kubernetes, you can expect about 6 decent. 6 is a good amount of, it's a decent package.
Okay.
But if you go to 6, your number of offers will come down. So my suggestion is you start with 4. You tell them I'm okay with 4. You work somewhere for 6 months, then take a jump. Then you go to 6 or 7. So your average annual salary is actually going to be more. Let's say you settle at, you are adamant at 6 and you stick to a single company, you will make 6 lakhs in that 1 year. Instead of that, follow my strategy. You go ahead with 4, stay for 6 months. So how much you will make? 2 lakhs, right? In 6 months. Then you make a jump at 6 months and you make the jump for 7 lakhs. So for the last 6 months, you will be getting 3.5 lakhs. So 3.5 lakhs and initial 2 lakhs. So total you got 5.5. But your package CTC at that point is about 7. So then you make another jump after 6 months.
Okay.
Then probably you will jump to 10 directly.
Sure.
So initially, a lot of people are scared of jumping. I suggest you make a jump every 6 months in the first 2-3 years.
So actually, right now, just I am learning all these courses are full stack and all these are DevOps, AWS. I have not joined any companies right now.
Too much learning is not really required. You should be more actively looking for a job. People, companies don't really need, a resource who knows everything. It's okay if you know only 50%, but you should be able to present it really well. Confidence, other things matter. Means, you learn Linux, right? So how confidently can you present Linux? If I ask you, okay, how many commands you know in Linux? So can you quickly tell some 20 commands? That's what makes the difference.
Right, sir.
A person who can quickly, say 20 commands. Let's say you mugged up those 20 commands. You said, okay, I know cd, chon, ls, tar, grep, ps. Then you just mug it up, kind of. Now, the moment you present it like that, people are really impressed. Oh, this guy knows whatever he knows, he can tell it. That's the most important thing. It also gives an impression that, okay, if I teach this person another technology, he will learn it and he will be efficient in that technology also. That's the thinking. So let's say if I ask you, tell me 10 Linux commands and you quickly tell me those 10 Linux commands, I'm really impressed. Then I start to think, okay, this guy knows CoreJava. I can take him to Spring and Spring Boot in about 2 months. I can teach you Spring Boot in 2 months. It's not a big deal.
Yes.
But I have to, be convinced that you can actually learn it. And that I will know only by your answers. So my suggestion to all the people who are freshers or anybody who is, focus on presenting really well. Even if you know little, focus on presenting. You have to prepare the presentation. The questions are again standard questions. People will ask you standard questions. It's like a leaked question paper. DevOps questions are standard questions. You won't get too many questions. But if you answer the answers, if you practice the answers, your chances of getting a job are more. Don't learn too many things. It's not necessary. As an interviewer, we don't really look for too many things. Too many things are in fact bad things. We ask you, why do you learn so many things? Why didn't you get the job in spite of knowing all these things? Isn't that a valid question? It's a valid question, right? So a resume has a lot of things and still you haven't had a job. Why? So those kind of things will come up. Just focus on few things. Be good with those things.
Yes.
So because you are already learning Spring Boot, I think at Spring Boot you can stop. Spring Boot is a good point. And you add DevOps with your Spring Boot. Either you can jump to DevOps side, operation side, or you can jump to full stack. I think you will get a full stack Java job much faster than a DevOps job because that's more popular than DevOps. DevOps people usually are more seniors. They look at. They probably some company, a big company, will take you as a fresher, so put you on bench, and then looking at your resume, they might push you into a DevOps or full stack. Anything is fine.
Right.
All right, guys, that's all. Thank you very much. I'll see you tomorrow.
Yes, sir.
Yeah.
Hello. Sir, I saw this word DevSecOps most of the times, but I don't know whether what is the difference.
This is
between...
after the DevOps. Once you are a DevOps guy, what happens is the security part in DevOps, they're implementing at the development stage itself. So you see this thing, this image that we have.
Yes,
earlier, the security used to be here in production. Means operations people used to focus on security. Now the security is being moved to the left. It's called shift left policy. So the developer has to implement security itself. That is called DevSecOps. Now to do that, the operations people have to help the developer. So both developers and operations people will learn the security part. And this is a new area that's coming in now. But it's not a wide implementation right now. Probably it will pick up in next 2-3 years, but right now, your dev and ops is more than enough.
Yes, sir. Yeah. DevSecOps in that is sec is security.
So
right,
give
sir?
security. Yeah.
Okay, fine. And is there any tools like we have DevOps in some of the tools like Terraform, Kubernetes, Docker, like any other tools in DevSecOps? Or
DevSec tools, yes, there are other tools like Truffleheart. Then you have SonarQube,
yes,
you have
the
Aqua.
SonarQube. Mhm.
Aqua you have. Then you have DAST, JAP proxy,
Okay.
Sync, Snick. This is. Then you have digital AI. There are a lot of tools in security. These are main tools. Each one of them will do one thing. This is for security scanning. This is for code quality check, and then this is also for static code analysis. This is dynamic code analysis. This is for again code quality check. Then you have what is called Trivi for container scanning. Then you have Kubernetes checking, kubesec. That is completely for Kubernetes. So there are a lot of tools. There are a bunch of tools here.
Yes. Yeah. Digital AI means regarding that is related to AI tools, right? Artificial intelligence.
No, digital AI is purely DevOps. Their name
Okay,
is
okay.
digital AI.
Okay. So, no, what is that one, sir? Digital AI means what is the abbreviation like?
Digital AI is a company.
Okay.
Digital.ai. They are, they just bought that domain, digital AI, but it's basically DevOps tools.
Okay, that is
They say,
different. Digital AI different and AI artificial it is different, right? Sir?
that is OpenAI. What you are talking is
Okay.
that is OpenAI, which is another company which created basically a recent popular chat GPT. They also have other AI products like DALI. Then they have another product also, which will do a lot of text to image processing, then question to answer formatting, this kind of thing. They all depend on the backend language learning model, which is a artificial intelligence system, which depends on machine learning.
Nice. But digital AI, that is not artificial intelligence, that is company, right? So
Intelligence is just a software company that provides
okay.
DevOps tools. They say their tools are implementing the artificial intelligence, but I haven't seen anything artificially intelligent in their products. They're just regular products like Jenkins. They say, you see this thing? They say AI powered DevOps platform. There's nothing really AI powered in that. They are just basic, normal logic. There is no machine learning, nothing. We haven't seen it.
Okay.
All right. Okay, guys.
Yes, sir.
Thank you very much. I'll
Thank
see
you,
you
sir.
again
Thank you.
tomorrow. Yep.
Okay, thank you, sir.